Hi, so now we will talk about mass spectrometer, a very important technique in science. This spectrometer is used to measure the mass of ions, very tiny object. It can even measure the mass of different isotopes of the same element. How it works? The mass spectrometer has three important parts. The source is where the ions are produced from a sample. This ion will be accelerated through difference in potential by applying either difference in potential or an electric field, so they will be accelerated and eventually enter a region of a magnetic field, small chamber here of a magnetic field. The ions will be deflected through circular path, or more exactly semicircular path, and they will hit a detector. And the machine will calculate the distance x shown here. So for example, in this problem, we have the magnetic field strength, uniform, 80 millitesla, the voltage used to accelerate the ions, the charge of that ion, so we assume a positive ion here, and the machine will give me this distance. So the question is, from this distance x, how I can calculate the mass of that ion. So let's get started. So we will be solving this problem in two steps. The first step, we will use conservation of energy to get the velocity of the particle of the ion when it enters the magnetic field region. So I want this V. So basically the ions start from rest. So conservation of energy you can write it as the potential energy, QV, will be converted into kinetic energy, half mv squared. And here we get the relationship between the voltage, the charge, the mass that we are looking for, and the speed. Okay. Now, the ion will have this speed, and it will enter a magnetic field region. What will happen to the charge? It will be following a circular path, semicircular path. What is the radius of this path? R is equal mv over qb. What is the distance x? Well, in the drawing, x is twice r. So x is equal to r, so 2 mv over qb. So that's my first equation. That's my second equation. From these two equations, I need to calculate the mass. So how we will do that? I take the second equation and I square it. So you will have x squared equal 4 m squared over q squared, b squared, and velocity, speed squared. What is the square of the speed? I can get it from the first equation. So we have still 4m squared over q squared, b squared, and v squared, that's 2q v potential over m. So this will give you 8 m squared and m. We have m, v, the potential, over q squared and q. We'll have q in the denominator and b squared here. So from this equation we can get the mass, which is equal to q x squared b squared over 8v. So numerical application will give you the mass equal to 3.38 10 to the power minus 25 kilogram. So that's how we calculate the mass of ions in mass spectrometer. Actually, in the mass spectrometer, what we will be using practically that's the mass over charge ratio, which is equal to x squared p squared over 8v. So if I have different mass, what will happen? So if I have different mass, basically, if you look at this equation, R equal mv over qv, if you get a different ion with different mass, let's say same element with different isotopes, so it has different mass. So basically what we will have, if you send them with the same velocity, what you will have different radius. Okay, we'll have a different radius. If you change the mass, if you lower the mass is smaller, so you will have a smaller radius. Okay, thank you for watching. See you in my next video.